Hi everybody, we are starting Unit 10 today, which is trigonometry. This is actually chapter 12 from the book, so in case you happen to be doing anything in the book, we know sometimes the unit names and the chapter names are a little jumbled up, so just an FYI, this is 12.1 we're starting today. We're going to look at the trigonometric ratios. Okay, so that's the first thing to keep in mind, this word ratio. When we see this, we think of a fraction. That'll be an important piece of today's lesson. Okay, so trig, you can call it for short, is the study of the relationships between the sides and the angles of triangles. We're going to look at the three trig functions that we'll learn in this lesson. They are called sine, cosine, and tangent. You may be familiar with these three buttons on the calculator, or at least you've seen them before. Those buttons are for sine, cosine, and tangent. You can see they're abbreviated a bit. So SIN, we actually say sine. We don't want to say sin, cos, and tan. You should say the full thing. So when you're talking about them, it's sine, cosine, and tangent. Okay, so we're going to learn what they are today, how to set them up, what they look like, how to use the calculator. There's quite a few things that we need to go through. Now, the first thing that we need to be able to do is to properly label our triangles, the sides and angles. So let's go ahead and just sketch a right triangle with me. And then we're going to pick one of the angles. It doesn't matter which acute angle you use, but we're going to pick one of them, and I'm going to put this little symbol there. This is the Greek symbol theta. Theta. It is typically used in a math setting to represent angle measures. So we're going to call that angle theta, and it could have been the other one, but let's just stick with one for now. By the way, when we work with these trig functions, we never reference the 90-degree angle, at least in our lessons here. When you get to other math classes, you'll use that one, but for now, we're never going to work with that 90-degree. Now, based on that angle, we're going to label our three sides. Now, the one that is the same no matter what is the hypotenuse. We know that from previous lessons is across from the right triangle. So that side is always the hypotenuse no matter what. Okay. The other two sides change based on which angle you are referring to. So if we're talking about this angle here, all the way across the triangle, this is going to be our opposite side. And then the one that's right next to, look where I'm jumping right from the angle to this side, we call that the adjacent side. Think about the meaning of that word, adjacent meaning next to. Now this can get a little tricky because if you're standing in this angle, it could be tempting to call this side the adjacent side, but it already has a better name. It's the hypotenuse no matter what. So we never want to call that the adjacent. Now, just a little note, and don't put this in your notes, but if we were to flip to this angle, call this theta. Now this would be the opposite, and this would be the adjacent. This one would still be the hypotenuse. So those labels change based on where you're standing. And you can, if you need a little bit of help labeling those sides, I posted a quick little video of my daughter actually teaching you how to do that. Now the reason that we need to be able to label those appropriately is because when we talk about sine, cosine, and tangent, it is just setting up ratios of those side lengths. So here's what sine, cosine, and tangent are. Here is their definition. And just watch how we're writing this here. I'm going to put SIN, and then I'm putting theta right after it. Now that is not sine times theta. This is not multiplication. If you plug that into your calculator, you'll actually get a parentheses that pops up right away. We're going to read this as sine of theta. We're plugging some degree measure into the sine function. Okay, so sine of theta by definition is the ratio of the opposite side, I'm going to abbreviate that opposite, to the hypotenuse, HYP. Okay, that's what sine is. So when anytime you were talking about sine of an angle, it's basically just taking the lengths of those two sides and dividing them. Some number that you get. Cosine of theta, putting parentheses around that, that's not multiplication, we're plugging it in, is equal to this ratio. The length of the adjacent side to to the hypotenuse. And then tangent of theta, you can write it without the parentheses, by the way, is equal to this ratio, the opposite side to the adjacent side. Now, we have a little tool that we use to help us remember that. And kind of this funny little word we make up to just help us remember, which ratio goes with which trig function. So what we're going to do is take the first letter of each piece of this and turn it into a word. So I'm going to take the S from sine, the O from opposite, and the H from hypotenuse, and we're going to write S-O-H. Likewise, we're going to take the C-A-H and have that here. It's all attached, kind of all one big kind of funny word we're going to write. And then same thing here for the tangent, take the T, the O, and it doesn't look like that, but that's an A right there. Let me fix that. Adjacent. So T-O-A. So you may have heard this before in a math class, or maybe you have an older friend that's had geometry before, and you've heard them say SOHCAHTOA. That funny little word we make up is to help us remember what those ratios look like, which trig function is which. So as you're going through this, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. You do have to make sure you can spell that correctly. And then tangent is opposite over adjacent. So that will help us set up these trig functions. Okay, so our first example, we are going to here. Just, you know what, we don't need to write this out. Let's just do the problem here. Let's draw a right triangle. And let's put some side lengths we're familiar with. How about 3, 4, and 5? And then this time we're also going to label the angles. So I'm going to put capital A up here, a capital B, and a capital C. Remember, those go on the vertices. So we're going to find sine of, let's say, angle A. Now here's what I'm going to suggest for every single right triangle trig problem that you do. This feels a little silly, but I do think it's helpful. I want you to draw a little stick figure in whichever angle they're talking about. So I want you to, and the reason we're doing this, I want you to kind of imagine that you're standing in that angle. So where you're standing there, we're going to label our sides now. So across from where you're standing, this is our opposite side. The 3 is the adjacent side because the 5 has to be the hypotenuse. So of course the 3 and the 5 are both next to you if you're standing here, but the 3 has to be the adjacent because the 5 is the hypotenuse. So sine, by definition, is opposite over hypotenuse, or let's just look at how we've labeled this now, 4 over 5. If you were working with this in your calculator, you'd be getting decimals, so 0.8. Okay, it's just the ratio of those two sides. Cosine of that same angle, angle A. Now this one's adjacent over hypotenuse. So this one is equal to 3/5, or you could put 0.6, that's fine. And then tangent of angle A is opposite over adjacent. And we're just looking at our labels here, so we've got 4/3. That's it, you stop there. Okay, so if you know the sides and they're asking you for sine, cosine, or tangent of an angle, it's just set up the little fractions, plug in your lengths into those sides. By the way, it might be helpful if you don't have this on the same paper in front of you to write down SOHCAHTOA. That will help you remember how to set them up. Again, make sure you can spell it correctly. Now, here's what you kind of need to pay attention with. If we change the angle that we're talking about, I'm going to rearrange some things on mine. You don't have to do this on yours because it's just going to be a mess. But I'm going to now move my person to angle C. Okay, so let me get rid of my little labels here. Okay, so now I'm at angle C. So now I want to find sine of angle C, cosine of angle C, and tangent of angle C. Okay, so now my labels based on where we're standing, the opposite is here. It was here before when we were in angle A, but notice now it kind of flip-flops. The adjacent is here. The hypotenuse, whoops, it's not all attached. That, oh boy, sorry about that. Go back. It's running away. Go back. Oh boy, sorry guys. Oh gosh, I didn't realize what I was undoing there. Okay, this is a disaster. Opposite and adjacent. Okay, there we go. Okay, so now sine of C, we have now opposite over hypotenuse is 3/5. Notice that was, look at these two numbers. When I switch my angle, my opposite and adjacent side flip-flop. Okay, if you can see that in the numbers there. Cosine is adjacent over hypotenuse, so 4/5. And then tangent is 3/4. Look how these two compare. Reciprocal, right? We had opposite over adjacent, but then those sides flip-flop, so they flip-flop. We're looking at its reciprocal. Okay, so that's kind of problem number one that you could see. Problem number two. You may be asked to find sine, cosine, or tangent of a particular angle measure. Now, in this problem, really all it's saying is just put it in your calculator. So I want you to go ahead and do that. Write down what you get. Are you getting 0.5? I'm going to guess that most of us actually are probably not getting that right away. You did nothing wrong. There's just something we need to do in the calculator. So if you got negative 0.988, we just need to change a setting in our calculator. So I want you to find the mode button right here. If you have a different calculator, not a TI, like 83, 84, something like that, just look around for where it says mode. It probably will say mode or like settings or something like that. And then what we want is this word right here to be highlighted. Make that a little smaller. We want degrees. Okay, so we're looking for this. The default setting in your calculator is actually radian mode, but we don't want that. That's a totally different way to measure angles that we know nothing about yet. So we don't want radians, we do want degrees. Now, just a note, when you turn your calculator off and on, it should stay in degrees, although I would double check. Okay, you could just remember this one, plug in sine of 30. If you're not getting 0.5, you're in the wrong mode. When you reset your calculator, if the batteries die, it is going to go back to radians. So when you're doing trig functions, these next couple lessons, just make sure right off the bat that you are in the correct mode. Okay, so a problem like that, you literally just plug that in. Now I want to talk about kind of what that means. The trig functions conceptually, I think, are very challenging. It's hard to grasp what it is they're asking you. So here's what this means. So let's think about a 30-degree angle. Now we lately have been working quite a bit with 30-degree angles because it's in one of those special right triangles. So draw 30, 60, 90 with me. And let's draw kind of our most basic one where the sides are 1, 2, square root of 3. Okay, short side, short leg 1, hypotenuse 2, longer leg, the square root of 3. So sine of 30 degrees, if I'm standing right here, sine, think about SOHCAHTOA, is opposite over hypotenuse, or 1/2, which we know is 0.5. But your calculator doesn't really have that triangle set up in there. So here's what it really means. In every single triangle with a 30-degree angle, that ratio, that fraction, opposite over hypotenuse, will always reduce down to 1/2 or 0.5. Okay, so another example to maybe drive home this point here. Let's imagine we drew that same type of angle, a 30, 60, 90, but let's pretend it's 3 times bigger. Don't worry about it being perfectly to scale. So we've got a 30, 60, 90. Okay, now I'm going to put, instead of 1, 2 square root of 3, I'm going to put 3, 6, and 3 times the square root of 3, right? It's 3 times bigger. I'm just stretching out all of those sides, but keeping the angles the same. So now sine of 30 from this triangle is opposite over hypotenuse would be 3 over 6, which is still 1/2 or still 0.5. Okay, so in every triangle with a 30-degree angle, if you took sine of that angle, if you took the opposite over the hypotenuse, you would get 1/2, or it would reduce down to 1/2. Okay, so sine of 30 degrees always equals 1/2 or 0.5. Okay, you might see a couple other examples in a bit that say, you know, find cosine of 52 degrees, find tangent of 73 degrees. We're literally just putting those in the calculator and getting a decimal for those. Okay, 2 more practice problems here with you. I want to set up maybe just, well, let's see. We'll see how this next one goes. Okay, you don't need to necessarily write this down. Just draw the triangle with me. So it says, given a right triangle, that's important, by the way. I should have mentioned that at the beginning. We're not going to use anything with sine, cosine, or tangent if we don't have right triangles. Okay, for now anyways. Okay, so the leg adjacent to a 31-degree angle is 36 meters long. Find the length of the leg opposite the angle. So let's just draw a right triangle. By the way, you can face it any direction you want. It doesn't always have to be positioned this way. So we have a 31-degree angle. My scale doesn't have to be perfect, but that looks like the smaller of my two. So I'm going to put 31 there. The leg adjacent to that has to be this one. Remember, this is the hypotenuse. Actually, I'm not going to label that now for a reason, but keep in mind that that's not the adjacent side. Find the length of the leg opposite the angle. So we're going to find x over here. Now, I am going to suggest you actually don't put anything on this third side. So the third side being the one that we either don't know its length or we're not looking for it. So the only labels we're going to put on there are the angle that we're given, and then 2 of the sides, the one we know and the one we're looking for. Now we're going to set up our little labels with the little stick figure person. So draw your little person in the 31-degree angle. Based on where you're standing, let's label our side. So this is the adjacent. This is the opposite. If we think about SOHCAHTOA, just keep this at the top of your paper. I would write it down every time. We're looking for, okay, which of these trig functions uses opposite and adjacent, or we're looking for O and A. So we kind of go through our 3 different options here, and you can see with the last one, there's the O and the A next to each other. So we're going to pick the letter before it. We're going to use tangent. So once you've labeled your triangle, so let's go through this. Step 1, label your triangle. Step 2, choose a trig function. So tangent of theta is equal to opposite over adjacent. Just write out what the equation says. Step 3, plug everything in. Did I already use step 3? I forget. So tangent of the angle. It's always tangent or sine or cosine of an angle. Don't put a side length here. That is equal to opposite over adjacent looks like x over 36. And then we are just solving for x. So right now on the right-hand side, we're dividing by 36. So let's multiply both sides by 36. Whoops, not 3.6. Oh, sorry about that. Erase. Okay, so we have, they cancel it over here. So we just have x on the right-hand side, and then you're literally just putting this in your calculator. Now, a little note, when you hit the tangent button, parentheses is going to pop up. Make sure you close it right away. If you plugged it in just like this, you wouldn't have any issues, but let's say you put the 36 like here. We don't want to accidentally plug 36 into the tangent function. That really is multiplication right here. Okay, so that should be about, let me see, what 21.6 meters. Okay, that would be how long this side would be. Okay, another one, same kind of setup here. Find the length of the hypotenuse this time of a right triangle. If an acute angle measures 20 degrees and the leg opposite that is 410 feet. So let's change it up here. I'm going to draw mine this way this time. Right angle, 20 degrees. We're going to find the hypotenuse. So I'm putting x here. The leg opposite that is 410 feet. Here comes our label. So little stick figure first. We're putting a little stick figure in the angle that we're either, well, for now, for today anyways, the angle that we know we have. Never the right angle again, remember that. Based on where we're standing, this is my opposite side. This is my hypotenuse. So think about SOHCAHTOA. We are looking for, where do we have the O and the h, right, opposite and hypotenuse next to each other, and it's right here. So we write down the function. Sine of theta is equal to opposite over hypotenuse. Plug everything in. Sine of our angle that we know, 20 degrees, is 410 feet over x. Now this one's set up a little bit differently than the last one. We are looking for x, but it's in the denominator. We are not multiplying by 410. If you did that, they would not cancel out. Okay, so what we actually are going to do, and it doesn't feel very productive at first, but we're really going to multiply by x. So no matter which way this is set up, you're always multiplying by the denominator first. Now on the right-hand side, they cancel out, which is fine, but notice it puts it over on the left-hand side, which is not super helpful because x is still not by itself, but at least it's quite a bit easier to get it all by itself, okay? Now, sine of 20, if you recall, is just some number in your calculator. Let me plug that in here. Sine of 20, it's about 0.34. So let's kind of take a step back. What we know is that if we have a 20-degree angle and we take this ratio, it should be about 0.34. So we're trying to figure out how big does this hypotenuse have to be so that this fraction is about 0.34. Okay, so just keep in mind that this is just a number. I only say that so that the kind of algebraic work is as easy as can be. We're just dividing by this number. It's just, I'm not going to put the decimal there. We want to avoid rounding error if we can. So we're going to divide both sides by sine of 20. So it looks like this now, and that is exactly what you'll put in the calculator. 410 divided by sine of 20 degrees. Remember, that's really 410 divided by 0.34, but let's just keep it exact. All right, that one we get for the length of that side, about 1198.8 or so. Okay, so they're saying that this hypotenuse would have to be 1,198.8 feet to get this correct ratio to show up, to get these two sides when I divide them to be 0.34. All right, if you didn't already print out this trig practice worksheet, please do that. Let me just make a note to kind of help you get started. The first four are plug in the calculator. The next four are just use the sides that are there, set up the little fractions. And then the last group, you are actually going through the whole thing. Put your little stick figure, label your sides, pick your trig function, and then solve your equation from there. Okay, so right now, go ahead and try those on your own. You can pause the video and then come back and I'll go over a couple of them with you. Okay, so go ahead and check the first four answers. If you are not seeing those, the only thing I think that could be wrong is you are not changing the mode in your calculator. So again, if you need to go back and rewind the video to see how to do that, make sure you're in degree mode. Also, I guess I should note, make sure you're not hitting the second button and then sine. If you're seeing this sine with a little -1 after it, that's called inverse sine. That's coming up in the next lesson. So we're not using that yet today. Okay, so just first four, plug them in. The second group here of problems, go ahead and check these. Let me go through one of them with you. Now you do need to be careful about kind of how you choose the side lengths you're going to work with. So cosine of x, this is where our little stick figure would be, an angle x, and we want the adjacent over the hypotenuse. So if you just had 9/41, that is absolutely correct. You can leave your answer like that. They just said to round it. If you look at the directions, they're round it to the nearest 10,000th. So I actually wouldn't mind if you want to leave them like this, totally fine. Okay, sine of A initially came from 35/37. Okay, that's again standing in angle A, picking the opposite over the hypotenuse. Number 7, tangent of A, you're standing here, opposite over adjacent, 16/12. That's where they're getting that 1.333 repeating from. And then sine of Z, you're standing here, opposite over hypotenuse, 32 over 40.8. Okay, now the next group, this is, you kind of have to go through the whole process here. So let me, in fact, if you want to just check your answers first, go ahead and do that. You can probably stop the video if you are good with those. Okay, if you did not get every single one right, please do another one here with me. So let me just pick, how about number 11? They're all very similar. So we're gonna, this is very similar to the two that we did together. Put your little stick figure in the angle that we have, never the right angle. From there, we're gonna label the side we have and the side that we're looking for. Whoops, that is not the hypotenuse. Let me back up here. That's the adjacent side. Okay, so you should have SOHCAHTOA written down somewhere handy that you can reference it. Okay, opposite and adjacent tells me I'm going to choose tangent. So tangent of my angle, theta, is equal to opposite over adjacent. Now this is the slightly harder one to get x all by itself. We're going to multiply both sides by x first. They cancel out over here. We just have 15. Notice x now pops up on the left-hand side, which is fine. Now we just need to get rid of this tangent of 55. So we're going to divide both sides by tangent of 55 degrees. And that's what goes right in your calculator, 15 divided by tangent of 55. Okay, let me pick one more here with you that's not tangent. Let me a second to look at this. How about 13? We're going to stand in the 71 degree angle. We've got opposite and hypotenuse. That means if I'm looking at SOHCAHTOA, that I'm going to choose sine this time. So sine of my angle is equal to x over 16. This is the easier version. It just takes one less step. This one, and in both cases, notice we multiply by whatever the denominator is first. But it just so happens in this one, we get x by itself right away. So we're just putting in the calculator 16 times sine of 71 degrees. That's about 15.1. Okay, if you need help with any of the others, please let me know. If you want to maybe check back, I might, if I have a lot of questions, we'll probably do a Google Meet later in the day. If nobody emails me, then we won't. So just watch the Google Classroom for that announcement. Tomorrow, we're going to do what we call the inverse trig functions, and then the next day we'll practice just a bunch of these practice problems. Okay, that's all for today. Have a great one.